Had some technical difficulties with the last video, so I'm going to finish the last problem here. We were talking about linear cost functions, linear revenue functions, and linear profit functions. The linear cost function for producing X cups of lemonade is the first thing we're looking for. At a summer art show, a vendor sells lemonade for $1.50 per cup. The cost to rent a booth at the art show is $120. Furthermore, the vendor knows that the lemon, the sugar, and the cups collectively cost 40 cents for each cup of lemonade product. All right, now remember that the cost function will be, in this case, the cost of 40 cents for each cup. We're going to produce X cups plus any fixed cost, which would be the cost of the booth, renting the booth, of $120. And that's our cost function. And it is a linear function in slope-intercept form. Write a linear revenue function for selling X cups of lemonade. Well, if the vendor sells $1.50, not $150, $1.50 per cup of lemonade, then the revenue function, R of X, is going to be $1.50 for each cup times X. A linear profit function for producing and selling X cups of lemonade, well, profit is going to equal revenue, your sales, minus your cost. So our profit function here will be our revenue function, 1.50x, minus all of it, in parentheses, 0.40x plus 120, or it's like a -1 there that I distribute by. This would be 1.10x minus 120. So that's our profit there, our profit function. How much profit will the vendor make if 50 cups of lemonade are produced and sold? Well, 50 cups isn't very much. I hope he makes some money on this deal. I'm going to find P of 50. So that's going to be using here, 1.10 times 50 minus 120. Well, 1.1 times 50 is 55, minus 120 is, negative 65. So the vendor didn't make any money. The vendor lost $65. Not so good. At $1.50 a cup, he or she's going to have to sell a lot more cups of lemonade here. Over here to this problem, how much profit will be made for producing and selling 128 cups? Now that's a pretty big jump from 50. Maybe this is going to be profit here. So P of 128 would be 1.10 times 128, going back to the profit function here, minus 120. So this is going to be 128, 1.1, one decimal looks like 140.8 minus 120, or 20.8. Well, at least it's positive. So the vendor profited by, maybe this is poor wording, made a profit of $20.80. The vendor profited by. Okay, I'm sticking with it. I didn't have much space anyway. Now, the last one says determine the break-even point. In business, break-even means there's no loss, there's no profit. You break even. Well, at 50 cups, we lost money. At 128 cups, they made money. So it's somewhere between 50 and 128. Well, the break-even point occurs, if you think about it, when the revenue is equal to the cost, because that means that the profit is going to be, if these are equal, is going to be 0. So what I'm going to do is I'm going to take the profit equation and I'm going to set it equal to 0. Now this might not come out exact, and it didn't say round to the nearest cup. I'm just going to have to assume it's rounding to the nearest cup of lemonade. But I'm going to solve this equation. I'm going to add 120 to both sides. And I have 1.1x is equal to 120. I'm going to divide by 1.1. And not that I can do this arithmetic in my head, but I've done this one before, if I'm not mistaken. turns out to be 109.1 if I'm not mistaken. So in this case, the break-even point is 109 cups of lemonade produced and sold. And finally, the end to this very long business application.